let's start today's daily question. So this question is a medium level, but I won't rate it as a medium because here all you have to do is find a normal logic to this question and have a good hand over if else statements that we have. Once the logic is done, this I would categorize as an easy question. So let's start. Let's start by reading this question first. So the question says there are n cars on a long road. So these cars have three directions to go. So one direction is left, one direction is right, and another direction is it is standing still. It is going in neither of the directions. Now what do these cars do? They collide. When two cars move in opposite directions, they collide. So if a car is moving left and a car is moving left, a car is moving right, then these two collide. And once these collide, the number of collisions should be increased by 2. When a car is stationary, the number of collisions must be increased by 3. That is, one car is stationary and either a car comes from the left side which is moving to the right, or a car comes from the right side which is moving to the left. Then we have to add 1. That is the question. Now we have to give them the number of collisions that are happening on the road. So I'll explain it to you really simply. So just think of this. We'll have 3 cases now. One is the car is moving left, or it is moving right, or it is stationary. These 3 are the main cases. So if the car is moving left, alright, and before all the cars were moving left, we have to do nothing. Let me show you this in a much simpler form. Now check out. Left, right, stationary. Left, right, stationary. If a car is moving left and before it all the cars were moving left, we do nothing. Okay? If the car is stationary and all the cars before it were stationary, we do nothing. Right? Now, if the car is moving right and a car is moving left, then also we do nothing. Only the counter, all the places over here, we'll have a counter. What will the counter store? Counter will store what the last car was doing. So it will be -1 for left, 0 for stationary, and 1 for right. So if the car is moving, if the car is moving left and the last car and the present car, so the present car is moving right, last car was moving left, so we do nothing. If the present car is stationary, last car was moving left, we do nothing. If the present car is moving left and the last car was moving right, there is a collision, so +2. If the present car is moving right, last car was moving right, we do nothing. If the present car is stationary, last car is moving right, we add +1. If the last car was moving left, the last car was stationary and the present car is moving left, we add +1. Now if the present car is moving right, last car was stationary, we do nothing. So this is the entire logic in a crux. Now some details we'll have to see. Now if these two are moving left, last car was left and the present car is also left, we'll do nothing. Once you have a collision, we will have a counter, either a 0 or a 1. That is, either we have stationary cars or we'll have cars moving to the right. These left cars that are there, that is the counter as -1, that will only be in the initial stage. So what do we do? Check. What do we check? If the initial cars were moving left. If the initial cars were moving left, ignore. Now next we start from here. So let me show you the loop for this. If we have direction as -1, direction, so let's make this smaller, simpler. If L is the present direction and the counter was -1, then we do nothing. If counter -1, then we do nothing. Else if counter, so I'll be denoting counter by these brackets. If the counter is 1, that is the previous car was moving right, then one thing we'll do, first add the collision with 2, and then this is one right car, and then we'll add the amount of right cars. What does this mean? Check. If a car was moving left and 2 cars were coming from right, this first collision will add +2, and then we'll have a stationary car. Then this car will add a +1 because it will bump or collide into this stationary car. That is what we are doing. We'll add a +2 and then we'll add right -1. So what we can do to simplify this problem is, we'll add to the collision plus equal to 2 plus right -1. That is what we'll do. Now else, if a car was stationary, and we were moving left, if a car before was stationary and we were moving left, we'll add 1. We'll add 1 to the collision. Now next what do we have? A car is moving right. Let me just clear everything. No, let's not clear. If a car is moving right, then what do we do? Counter is 1, that is the last car was moving right only, so we add. We'll have a variable called right and we'll add to it. If the last car was moving left, so present car is moving right, last car was moving left, we do nothing. If the last car was stationary, we are moving right, we do nothing. So all we have to do is update the counter to 1 and add right to it. Add right. That is all that we'll have to do. Now, if the car is stationary, what will happen? Everywhere we'll have these 3 cases. That's all. If the car is stationary and the counter was 1, if the car is stationary and the previous car was moving right, we'll add to collision nothing but right, whatever the right cars were. Think of it again. If we have 3 cars from the right, all 3 will bump into the stationary car. That is why we are adding. Now, if the previous car was moving left and we have stationary, we will do nothing. If the previous car was stationary, we will do nothing. Let me show you the code for this. Just this much. That was the logic. Check it over here. Let's compare. Now we are first updating the counter. Once we have updated the counter to the first direction of the car, let's check. So here, look at this block of code. We are moving to the left. Now if the counter is 1, we add right plus 2 plus 1. Then what? Once right has been consumed, the cars coming to the right will be 0, and the counter will be stationary, because left and right cars have bumped into each other, right? Also, if the car was stationary, then the collision will have to add, and as the counter was 0, we'll keep it as 0. No need to update the counter. Now next is, if the car was moving right, as you can see, we were doing nothing in -1 and 0. So we were doing nothing in -1 and 0. If it is moving to the R, to the right, we'll just increment the right and update the counter as 1. That is all we have to do. Next was if the car was stationary. What do? If it is moving to the right, over here, if it is moving to the right, we add right to it, and we have consumed right, so right will be 0. If the cars were moving to the left, we'll have to update the counter. That is all that we'll have to do. Update the counter. So this is the approach. This is the solution. So go through it. This is not that difficult of a problem. Just you have to be logical about it, using either diagrams or plain logic. That is all. Thank you so much, and let's meet tomorrow for another LEET Code problem. Thank you.